In this video, we'll discuss some basic concepts associated with the production possibilities frontier. The basic question we'll be addressing here is, what does it mean to produce efficiently? How can we get the most out of the resources that we have? There are a few assumptions we make when we construct a production possibilities frontier. That's also sometimes referred to as a production possibilities curve. So sometimes you'll see the letters PPF for production possibilities frontier, or equivalently PPC for production possibilities curve. Now, this relationship that we're going to be discussing is a relationship between two goods, and we're using two goods just because we have two-dimensional surfaces to graph this on, or this concept generalizes in a very straightforward manner to any number of goods. The basic assumptions we make when we construct a production possibilities frontier are that there's a fixed quantity and quality of available resources, the inputs that's used to produce the output. There's a fixed level of technology, and technology is a term we use in everyday use quite a bit, but the technical meaning of it is essentially the know-how of how to combine inputs to produce output. So when we draw this curve, we're assuming that the level of technology or our knowledge of how to produce output hasn't changed. We haven't come up with better ways to do it when we're working with a given production possibilities frontier. We're also going to be assuming that there's an efficient production process. And what that means in practice is two things: that there's no unemployed resources, which means that all resources are being used, and secondly, there's no underemployment of resources. And underemployment occurs if resources are not being used in their best possible use. So when we draw the curve, we're assuming we're using all of our resources and we're using them where they're best suited given the mix of goods that we're producing. Let's take an example that's going to be fairly relevant to you as you move through this semester: study time. Let's suppose you wake up one morning and you suddenly remember you have 4 hours left to study for two exams that are going to be given back to back 4 hours from now, one in economics and one in calculus. The output in this question would be your grades on each of these exams. The inputs would be those resources you have that would allow you to be more successful in these classes and on these exams. That would include things like your textbooks, any notes you have, any practice materials, etc., as well as your own time. But notice that these resources are in fact fixed, that between now and these exams, you're not going to be able to get any other textbooks or any other study materials beyond the ones that you already have. The technology here essentially refers to your study skills, how efficiently you can use the inputs you have to be more successful in mastering the material in these classes so that you can do better on the test. Saying that there's no unemployed and no underemployed resources means that you're using all of your resources and you're using them in the most efficient possible way. So you're using all of that time. You're not taking time off to text or to post to Instagram or Snapchat or on GroupMe and so forth, but you're using all that time and you're using it in the most effective way to be successful in these classes. This table shows 5 possible ways in which you can allocate your time between studying economics and studying calculus. In the first case, you spend all of your time studying economics and none of the time studying calculus. In that case, you'll end up with a grade on your calculus exam of 0, since you haven't studied any of the new material that will be covered on this. And you'll find you received a 60 in economics, which isn't a bad grade considering you only spent 4 hours getting ready for this test. Spending more time studying economics is always a good thing. But suppose you want to alter the combinations that you get in terms of your grade. If you transfer 1 hour of study time from economics to calculus, your grades on calculus will go up by 30 points. Your score in economics will fall by 5 points. Similarly, if you spend a second hour studying calculus, and give up 2 total hours studying economics, so you're spending 2 hours on each, your calculus score will go up to 55, your economics score will fall to 45, and so on as we move down the table. A couple of things we can note about this. One is each additional hour you spend studying calculus ends up giving you a higher score, but the increase in the score becomes smaller and smaller. Similarly, when you take an hour away from studying economics, the first hour you transfer away, you only lose 5 points. The next hour, you lose 10 points. The next hour, you lose 15 points. And in the final hour that you give up, if you give up that last hour you're studying, you lose a full 30 points on this exam. Now, when you think about it, this should make some sense, because if you're only going to spend 1 hour studying something, you're going to try focusing on those things that you think are most essential. So you focus on those things that you knew would be tested on the exam, and that would give you the largest gain for that first hour of studying. When you add another hour, you'd now study the next most important things, and so on, and each additional hour will give you less and less of an increase. That's a concept we'll be talking about very shortly, which is called the Law of Diminishing Returns. So these are just some possible combinations, and notice these are not the only ones, because you could spend, for example, a half an hour studying calculus and 3.5 on economics, or any combination between these endpoints. So that law of diminishing returns is a fairly important principle in economics, and what it says is that when we have some fixed resources, output will ultimately go up by progressively smaller amounts when you add a variable input to this production process where some other inputs are held constant. In this case, the study materials you have and so forth would be the fixed inputs. But in general, we expect this relationship to hold. Now, we can plot this relationship between calculus grades and economic grades as has been done in the diagram on the right. If you spend all of your time studying calculus, you get an 85. If you spend all of your time studying economics, you get a 60. So those are 2 of the points illustrated here, but the others would be other points on this curve. Now, one of the things we can do with this information is to find out something about the opportunity costs, because we notice the opportunity costs, the rate at which we're trading these things off, is not constant as it was on the budget constraint, but it seems to vary depending on where we are on this curve. Suppose we look at these first 2 points when you start studying only calculus and you take an hour away from that to study economics. Your calculus score went down by 10 points, your economics score went up by 30 points. One thing you might ask is, what is the opportunity cost of an additional point in economics? What we know is that when we move from point A to B, we gain 30 points in economics and we lose 10 in calculus. So the opportunity cost of those 30 economics points is 10 calculus points. So what will be the cost then of a single point on the economics exam? Well, if we know how much 30 units of something cost, the cost of 1 unit of that would just be 1/30th of it. So we divide both parts of this by 30. So if we know that the opportunity cost of 30 points is 10, the opportunity cost of 1 point would be 1/30th of 10, which is 10/30th, or just 1/3 of a point on the calculus exam. So if we start spending all your time studying calculus, to gain 1 point on the economics exam only costs you 1/3 of a point on the calculus exam. But let's see what happens as you start taking more time away from calculus to study economics. If we look at the interval between B and C, we see you're giving up now a bit more on calculus, and the gain you're getting in economics is a bit smaller. So between these points, the opportunity cost of the 15 points from 30 to 45 in economics is that you're giving up 20 points on your calculus exam. So the opportunity cost of 1 point on the economics exam is 4/3 of a point on your calculus exam. So you notice the opportunity cost of 1 more point in economics has now increased. Let's go back to our original table and examine how opportunity costs change as we change the amount of time we allocate to each activity. If we move from the first row of this table, where we're spending all of our time studying economics, and we transfer 1 hour to studying calculus, we see that the calculus grade will go up by 30 points, while the economics grade falls by 5 points. So in that case, we give up 5 economics points to acquire 30 calculus points. Since the cost of 30 calculus points is 5 economics points, each one of those calculus points would cost 1/6 of an economics point. If we move down for the next interval, when we go from spending 1 to 2 hours of studying calculus, we gain 25 points in calculus at a cost of 10 points in economics. So the opportunity cost of 25 calculus points is 10 economics points. So the cost of 1 calculus point would be 1/25 of 10, which would be 10/25 or 2/5. If we increase the number of hours studying calculus from 2 to 3, our calculus grade would go up now by 20, economics would fall by 15. So the cost of those 20 calculus points is 15 economics points. So the cost of each of them is 1/20th of 15, or 15/20ths, or 3/4. If we shift 1 more hour to studying calculus, we gain 10 points in calculus at a cost of 30 economics points, and the cost of each one of those 10 points would be 1/10 of 30, or 3. And what we notice is the opportunity cost of acquiring calculus points rises as we increase the level of time we devote to studying calculus. Now, while we could measure the opportunity cost of 1 point in economics by using the same process and moving up the table, we can also note that there's a reciprocal relationship between the opportunity cost of 1 calculus point in terms of economics and the opportunity cost of 1 economics point in terms of calculus. So, for example, if we know that each calculus point requires to give up 1/6 of an economics point, 1 economics point must require us to give up 6 calculus points, and so on. So once we know the opportunity cost of one good in terms of the other, the opportunity cost in the reverse direction is just a reciprocal relationship. And that's what's illustrated now in the rightmost column on this table. One of the things that this illustrates is a phenomenon known as the law of increasing cost. The law of increasing cost states that when resources are fixed, or when resources are specialized, the opportunity cost of producing additional units of a good will rise as the level of production goes up. Let's talk about each of those reasons. The first one is that law of diminishing returns, that as you spent more time studying economics, the gain became smaller and smaller. That phenomenon, though, is very general. Suppose you have a restaurant. We're dealing with a fixed amount of capital, a fixed number of tables, refrigerators, grills, etc. If you have one person trying to do everything there, they have to do the cooking, wash the dishes, clean everything, do all the food prep, serve the tables, bus the tables, wait on the customers, and so forth. If we add a second worker, you can divide up the tasks and you could get a pretty big gain and improvement. Eventually, though, as we keep adding more and more workers in this fixed amount of space, the extra output produced will start going up by less and less, partly because each person will get in each other's way. You've heard that expression, too many cooks spoil the broth. That may be the type of thing that we're talking about here. That if you have 2 or 3 people trying to work on a 4-foot by 4-foot griddle, they're going to start getting in each other's way quite often, and the extra gain from having that extra person there is likely to be very small. The same thing occurs, though, when resources are specialized. That if we have resources that are not equally good in all applications, it turns out we're still going to get that same sort of increasing marginal opportunity cost. Perhaps the best way of seeing this is through an example. Suppose we have a really simple economy where food is somehow freely available. We'll make it really simple here. And the only 2 goods are health services provided by medical care providers and homes being built by carpenters. Now, let's suppose that some people are really good carpenters and really bad physicians, while others are really good physicians but relatively poor carpenters. And some people will have a balanced mix of each of those skills. If you're producing only healthcare services, then what happens is that you're going to have some people there who are really good physicians and others who are not very good physicians providing health services. So the overall level of provision of that wouldn't be as high as if everyone was really qualified. Let's suppose we start at that point on the top left of the blue curve there, and we start producing some homes. So we're going to transfer some people from providing medical services to being carpenters to build homes. What will happen is the first people you transfer away from medical care would be those who really are relatively good carpenters. In that case, you get a relatively large increase in the number of homes being built, but you don't give up much in the way of healthcare services. So in that case, the curve is relatively flat because you're getting a large gain on the horizontal axis and you're giving up a relatively small amount on that vertical axis. But as you start producing more and more, you end up taking away people who are relatively better medical care providers and are relatively less good at providing carpentry service, until we get to the very end where we're transferring some people over who are really very poor carpenters, but who would have been relatively good physicians. And in that case, we're not getting much of a gain in terms of carpentry services, but we are seeing a large loss in healthcare services. In general, some land is better suited for some purposes than others. Some types of equipment or capital is better suited for some types of production than others. And as we start moving to one extreme or the other, we're going to be using more and more resources that are relatively less well suited to that task, and we don't get as much of a gain. So between diminishing returns and specialized resources, we have this concave production possibilities curve, this sort of bowed out shape. And that's the type of curve that we would generally expect to see occurring for pretty much all commodities. Now, if we have unemployed or underemployed resources, we're not producing on the production possibilities curve. Point A would be an example of that. So whenever we're not using all of our resources or we're not using them in the best possible way, we're below the production possibilities curve. Everywhere on the curve involves having all resources being used and being used in the best possible way. So whenever we're below the curve, we must have either unemployed or underemployed resources. Now, what about a point beyond the curve? Is it possible to achieve that? Well, the answer basically is no. We can't get to those points with existing resources. The only way we could get there is if somehow the curve shifts, and for the production possibilities frontier to shift, one of the things that we talked about earlier as being fixed would have to change. For example, we can have economic growth if we end up with more resources, if we have higher quality resources, or if we have improvements in productive technology. So any of those things would lead to economic growth, which would be represented by an outward shift in the production possibilities curve. Suppose we have some new breakthrough that allow carpenters to produce homes more efficiently. In that case, we'd see the curve shift out in a rightward direction, but that by itself would not increase our ability to provide healthcare services. So in that case, we'd see the curve pivot out along the homes being built axis, but not along the health services axis.